viewers. Today I will discuss about the Metamorphic Feces series, classification of metamorphic feces. Prior to this, we must know what is metamorphic feces. We have already discussed about the metamorphism, type of metamorphism and factor of metamorphism in our previous discussion. Now today let us see what is metamorphic feces. Barrow, while mapping the Valerian cyst of Scottish Highland, he was the first person to map that area and find out the zone of metamorphism on the basis of index minerals. And these are the index minerals, mainly chlorite, biotite, almandine garnet, starlite, kyanite, sylvanite. The presence of one index minerals like chlorite and disappearance of another index minerals can give rise to a different zones. Say for examples, if chlorite is present in biotite zone, suppose we'll observe the chlorite and biotite zone respectively, then the biotite is normally absent in lower zone. It means biotite is absent in chlorite zone, and while chlorite is present with biotite in a higher zone, and one line is demarcating where the both are present as a common assemblages. On the basis of these index minerals, which was first recognized by the Barrow in 1914, and on his names, these are known as BarrowVN type of metamorphism, and normally it is also known as a progressive metamorphism. And if suppose we will see on the basis of pressure and temperature concept, the BarrowVN type of metamorphism is normally intermediate type of pressure temperature phases. And later on, Telly also supported whatever the zone described by the Barrow on his Scottish Highland. He also supported same things and find the same result, that is the BarrowVN type of metamorphism. Now let us see on the screen the map of that area, on which we can see the different grade based on index minerals like chlorite zone, biotite zone, almandine garnet zone, starlite zone, kyanite zone and sylvanite zone. If suppose on the basis of that, we can see the chlorite indicate the low grade zone, while the sylvanite represent the higher grade zone. If suppose on the basis of that we divide the faces, then the chlorite represent the low grade faces, while the sylvanite represent the higher grade. On the basis of that, we can say the presence of chlorite to sylvanite is also indicate your green cyst to amphibolite to later on GEOLOGY faces. Later, mapping in the bookend region of the eastern Valerian revealed a sequence of progressive metamorphism that was different from Barrow zone. The bookend zone was biotite, cordierite, andalusite, sylvanite, and this sequence in fact represent the bookend type of metamorphism, and normally the andalusite sylvanite along with cordierite indicate a low pressure and temperature metamorphism, and this is known as a Buchan type of metamorphism. So both sequence you can see on the map, your BarrowVN type of metamorphism as well as Buchan type of metamorphism. During 1960, Mayashiro was mapping in Japan, and he found a slightly different type of metamorphism, particularly the low-grade metamorphism as well as high-grade metamorphism in Japan area. Particularly, he observed the sequence, see the map and assemblages, particularly on that area. Now let us see the concept of metamorphic faces. The concept of metamorphic faces was first conceived by the Oscola in 14 and 15 as per his classification. If suppose we will divide the metamorphic faces on his concept, particularly on the metamorphic faces series, we can see the division of metamorphic faces on the basis of pressure and temperature. Particularly, if suppose you will see the diagram on the screen, so we can observe the line which indicate the low pressure with increasing high pressure, high temperature, low pressure. The first faces, that is the pyroxene Hornfels faces, in which you can see the temperature is higher and pressure is also higher. Particularly, now look at on the screen for this diagram, and we can see the different faces are present. Normally, cyanidinite faces, pyroxene Hornfels faces, gaolite faces, eclogite faces. Suppose we will move towards low temperature side, amphibolite faces, epidote amphibolite faces, green cyst faces. Below this, the glaucophene cyst faces and geolite faces. Later, in 1958, Fye et al., Fye, Turner and Barughan, they have classified the metamorphic faces into two types based on pressure and temperature. And normally, on the basis of pressure, the pressure less than 4 kilobar and pressure more than 4 kilobar. Particularly, if suppose we will see these classification on the screen, we can observe the classification based on Fye and Turner and Barughan. As per these classification, the first is your regional metamorphism, where pressure is more than 4 kilobar. We can observe the following phases, namely geolite phases. The temperature varies from 200 to 400 degrees centigrade, pressure normally 4 to 5 kilobar. After that, glaucophene lawsonite phases. In this case also, temperature is nearly 200 to 400 degrees centigrade and pressure normally nearly 8 kilobar. After that, the green cyst phases, temperature is 400, 450 to 500, 550 degrees centigrade with pressure 4 to 5 kilobar. Further, with increasing temperature and pressure, the next phases is your almandine amphibolite phases. Particularly, these phases have a temperature range 500, 550 to 700, 750. Similarly, pressure is also more than 4 kilobar. And further is your gaolite phases, where temperature is nearly 700, 750 to 870 degrees centigrade. and further ahead, that is your eclogite faces, where temperature is high as well as pressure more than 8 kilobar. So these are the phases particularly in regional metamorphism, where pressure is normally above 4 kilobar. Now we look at another side where the pressure is normally less than 4 kilobar. We can observe following phases, mainly albied epidote Hornfels faces, hornblende Hornfels faces, pyroxene Hornfels faces, and ceridenite faces. If we compare both the classification, particularly the classification given by Oscola as well as the classification given by Fye, Turner and Barughan 1958. Now let us see what are the difference particularly in these two classifications. The classification given by Fye, Turner and Barughan 1958, they have divided the faces into two types, mainly the low pressure faces and high pressure faces, based on the mineral assemblages as well as pressure, particularly the thermal metamorphism, where pressure is normally less than 4 kilobar, and regional metamorphism, where pressure normally above 4 kilobar. And the following phases are in thermal metamorphism: albied epidote Hornfels faces, hornblende Hornfels faces, pyroxene Hornfels faces, and ceridenite faces. While in case of regional metamorphism, the following faces are the geolite faces, glaucophene cyst faces, green cyst faces, elmendine amphibolite faces, gaulite faces, and eclogite faces. Now see other differences also, particularly the Fye, Turner and Barughan, they have recognized two faces, that is albied epidote Hornfels faces and hornblende Hornfels faces, as compared to these two faces. If suppose we will see the third important difference, Oscola, they have a new faces that is known as a epidote amphibolite faces, while the Fye, Turner and Barughan, they have renamed epidote amphibolite faces as a green cyst faces. So these are the important difference, particularly in Oscola faces classification as well as Fye, Turner and Barughan classification. Later on, in 1960, Turner revised his classification, which was given in 1958, and classified the metamorphic faces into three different types based on mainly pressure concept: the low pressure metamorphic faces, intermediate metamorphic faces, and high pressure metamorphic faces. The low pressure metamorphic faces are, now look at on the screen and see these faces. They are normally the albied epidote Hornfels faces, hornblende Hornfels faces, pyroxene Hornfels faces, and ceridenite faces. If you move from epidote towards ceridenite faces, normally the temperature will increase and pressure also decrease. So particularly the ceridenite faces are usually found near the vicinity of intrusive body, where temperature is normally very high. In the case of intermediate pressure, we can observe four important phases, and these are normally known as intermediate pressure temperature phases, and they are geolite phases, green cyst phases, amphibolite phases, and gaulite phases. If you will move from geolite towards gaulites, the pressure and temperature normally increase, and the rock is normally dry from geolite towards gaulites. And last is your high pressure metamorphic phases, and in this phases normally we can find two phases. These are the blue cyst phases, that is glaucophin lawsonite faces and eclogite faces, and particularly in these faces pressure are normally very high, even more than 8 kilobar. So this classification was given by Turner and BarrowVN. Later on, Winkler in 1974-75 classified the metamorphic faces into different grades, normally a very low grade metamorphic faces, low grade metamorphic, intermediate grade and high grade metamorphic faces. And particularly the Winkler, he summarized his observation in his textbooks for third and fourth editions, particularly the Metamorphism and Petrogenesis. And if suppose we will see as per his classification, so we can observe the important phases, particularly in very low grade. Now look at on the screen and observe what are the phases particularly in very low grades. Lawmentite very low grade, lawsonite very low grade, glaucophin lawsonite very low grade, and jadeite quartz very low grade. If suppose we will move from lawmentite to jadeite quartz very low grade phases, the pressure is normally increased. Now look at particularly for the low grade metamorphic phases, and these are almandine low grade, glaucophin clinogeosite low grade. If suppose we will see the intermediate grade, that is your corderite intermediate, corderite almandine intermediate grade and almandine intermediate grade. And further the high grade, that is your corderite high grade, corderite almandine high grade and almandine high grade. Particularly right from very low grade towards high grade metamorphic phases, every phases are depend upon the specific temperature and pressure which represent the reactions. Say for examples, the lawmentite very low grade and lawsonite very low grade is normally merged as a geolite phases, because in this case the hollandite is normally changed into lawmentite if pressure is less than 3 kilobar, and hollandite change into lawsonite when pressure is more than 3 kilobar. So later on these two phases are normally merged as a geolite phases. Particularly if you will see the glaucophin schist phases and jadeite quartz phases, so these two phases is also merged as a glaucophin lawsonite phases, particularly where pressure is nearly 8 kilobar and temperature varies from 200 to 400 degrees centigrade. So particularly in very low grade metamorphic phases, they belong to geolite and normally glaucophin lawsonite phases. If suppose we will move from very low grade towards high grade phases, so higher grade phases is normally represent your green schist phases, and similarly intermediate phases represent amphibolite phases, and high grade phases indicate your upper amphibolite to granulite phases. These are the classification particularly based on pressure, temperature as well as BarrowVN type of phases which was observed by the Barrow, and side by side the similar observation given by Goldsmith in different area, particularly from Norway sites. And Oscola, he compared the result of Goldsmith, and later on he concluded as per the phases series, if the same assemblages with a different conditions, in the sense with a different intrusive body, the product will be different. In other words, If suppose we'll say, let us take an example, if calcareous assemblages and if the same assemblage is suffered by a confined pressure and temperature, fixed pressure and temperature, so we can predict the assemblages. Say for example, if we will take the case of amphibolite faces, if calcareous assemblage is there, like plesioclase, gracilorite, calcite with diopside, the assemblages diopside, wollastonite, plesioclase and diopside, gracilorite, calcite. If the metamorphism is suffered by same PT condition, then very easily we can predict what are the mineral form. Now let us see the definition, particularly about the metamorphic faces. As per the definitions, a metamorphic faces is a set of metamorphic mineral assemblages repeatedly associated in space and time such that there is a constant and therefore predictable relation between minerals composition and bulk rock chemical composition. A metamorphic faces, as defined above, is the collection of mineral assemblages from above of all bulk composition and crystallize at the same PT conditions. As we have already discussed about the calcareous assemblages, because if source rock is same and the pressure temperature is also fixed, then easily we can predict the mineral assemblages. Like if suppose you will see the amphibolite faces, then on the basis of that we can say the mineral assemblages are, particularly in calcareous assemblage, the plesioclase, gracilorite, garnet, calcite and diopside are important assemblages, particularly in calcareous. If source rock is calcareous and metamorphism is up to range of 500, 550 to 700, 750 at 5 to 7 kilobar pressure, which is normally for amphibolite faces. So these are the concept of metamorphic faces. Now let us conclude the today discussion about the BarrowVN type of metamorphism along with the bookend type of metamorphism. The BarrowVN type of metamorphism are based on index minerals, particularly right from chloride zone up to sillimanite zone, which increase the grain size as well as grade of metamorphism. Particularly in bookend type of metamorphism, normally this belong to low pressure temperature metamorphism, and mainly the andalusite sillimanite with the cordite are the important assemblages. Particularly the classification for metamorphic faces given by Oscola, Fye, Turner and Barrogan, particularly the low pressure faces, intermediate pressure faces and high pressure faces. And also we have discussed something about the concept of metamorphic faces. Now it's time to conclude the today topic, and I will discuss in my next lecture about the concept of metamorphic series and type of metamorphic series. Now it's time to say goodbye to all of you. Thank you very much.